Yes.
Hi, Jamie. Today I will introduce you a basic but very important concept in probability theory and statistics. It is random variable. Of course, random variable is a variable, but its values are obtained randomly. And in fact, it can attend on a set of possible different values with an associated probability. The mathematical functions that describe the possible values of a random variable and the associated probability is called probability distribution. And then based on the different properties of probability distributions, we can define random variables into three classes. The first class is called discrete random variable. It can and only can take values on a finite or countable list of values endowed with a probability mass function. And for example, we will consider the case of coin toss. If we ignore the extreme case, there will be only two results of the coin toss: the hand and the tail. So we can determine the random variable x. For example, if the result is hand, then we can let x equal to 1. And if the result is tail, we can let x equal to -1. So in this case, we can find that x can and only can take values on the list of -1 and 1. So it is a discrete random variable. And more specifically, if we define the probability that the result of the coin toss to be hand equal to p, we can write the probability mass functions as following. We can write that p of x equal to 1 equal to p, and p of x equal to -1 equal to 1 minus p. And this is the probability mass function of the random variable x. And in this case, the probability distribution of x is called Bernoulli distribution. And the second case is called continuous random variable. It can take any numerical values in an interval or collection of intervals by a probability density function. And for example, consider that I have an interval, for example, from 0 to 1. And then I randomly drop a point into the interval. And then I will assign x value to be the location of the point. So we can find that, in fact, x can take any numerical values from 0 to 1. And more specifically, if I can drop the points randomly enough, we will find that the probability that x is equal to any numerical values from 0 to 1 is equal. And then we can write the density function of x as the following: p of x equal to t is equal to 1 for any t from 0 to 1. And in this case, the random variable x, the probability distribution of x is called uniform distribution. This is the second case. And the third class is, in fact, a mixture of the first and second classes. So, for example, we can determine the random variable's value by the following steps. First of all, I will flip a coin. And if the result is, for example, is tail, then we can let x to be -1. And if the result is hand, we can then just randomly drop a point into the interval from 0 to 1, and let x be the location of the point. So we can find that x is in fact a mixture of discrete random variable and continuous random variable. And therefore, x is in the third class. That's all, thank you.
Good, thank you. So how do you use these running variables in your day-to-day work?
For example, because in our daily life, we can't For example, for the case of valuing forecast, we can let, for example, the random variable to denote the condition of weather. For example, let x equal to 1 for denoting for raining, x equal to 2 for snowing, x equal to 3 for sunny, and so on. And by studying the properties of the probability distribution of x, for x, we can predict the weather. For example, for the next few days.
Mm-hmm.
It is an application of random variables.
Okay. But what's your field again? Your field is?
Few.
Yeah, what are you studying again?
Statistics.
Statistics, okay. So you're strictly statistics. Okay, great. Well, thank you very much. And this is Mingrui. What's your last name, Mingrui?
Zhang.
Mingrui Zhang.